Good afternoon, everybody. Thank you for joining us today. My name is Jonathan Kratz. I'm the Executive Director for USGBC Texas, and happy to be co-hosting today's webinar. If you have any questions throughout the presentation, please add them to the chat, and we will bring them into the conversation as soon as we can. Either mid-conversation or toward the end, we will have a time for question and answers as well. Additionally, if you would like AIA continuing education credit, please request a certificate from either Steve or myself through the chat or at the end as well. So look forward to it, and I will turn things over to Steve to introduce today's speaker.
All right, thanks, Jonathan. So this is one of those great USGBC Small World stories that's kind of fun. Seems like about 3 or 4 years ago, I had this opportunity to put a solar powered pole mounted light / camera / Wi-Fi / everything here at the Houston Permitting Center in downtown Houston. I thought, wow, what a great idea. Anyway, it never materialized, and I did get the drawings, and I was kind of set up for it. And the first thing we were going to have to do is, get a pier drilling truck in here, and do the everything. So it was going to be ugly, and I'm kind of glad it never happened. All right. Meanwhile, that's about the time I think I might even met Jeremy for the first time, because he was the governmental relations guy with U.S. Green Building Council, and I don't know what brought him to Texas, but he came a couple of times and visited me here at the Green Building Resource Center. So fast forward to this year, and Jeremy's saying, "Hey, Steve, I'm joining this outfit, in Austin called PowerStack, and here's my product." And I went, "Oh wow!" Now I'm doubly glad I never got that other kind of. It was half weird looking. And here's this, and it just went, wow, this is great. So and then ridiculously small world, I had some friends in a nonprofit by the name of Spark in Houston. They do this Spark Park program where they help school playgrounds become kind of enhanced so that they can serve as a playground after hours, in the neighborhoods. And I've been, I've known them for a long time, and, helped them out when they've run into some permitting issues, if you can possibly believe anybody would ever have a permitting issue. And, but they were looking for some sort of devices like this. They had, a picnic table with a solar panel shade, and they wanted to use something like that. And I went, great, you're gonna have to get a permit. What? Our manufacturer was saying, no, we don't need a permit. And so anyway, it's kind of busting their balloon on that. But then the minute I saw this from Jeremy, I said, I sent it over to them and said, hey, this thing is dynamite, you should call Jeremy and take a look. So boom, I don't want to, spoiler alert, that's going to come up in the presentation. So I just kind of want to give everybody a nice little background about why we're talking about outdoor power reimagined. And there's just a host of things about this type of technology that I just couldn't wait to get out there to, the crowd here or the cloud. So you can see what's coming. And this is a real good one to start with. So Jeremy, take it away, man.
Thanks very much, Steve. And thanks, Jonathan, for hosting as well. Good to meet everybody here today and to be with the city of Houston, with USGBC Texas, and with all of you. Just a little additional quick background. I have spent about 20 years, actually a little bit more than 20 years now, in the green building industry. A lot of that was with the Green Building Council. Some of it was in green real estate development. Other parts of it have been sort of in study and practice related to water conservation and human health in buildings. And so I think the nexus of a lot of these issues is a passion point, certainly of mine, and I know of a lot of folks on the call. And one of the things that really brought me into this particular field, because there's a really nice nexus of cost saving, elegance, simplicity, and really solid engineering at the same time. So before we get into all that, I wanted to take a chance to orient you a little bit to today. We'll start broad, looking at some of the larger trends in solar energy deployment globally and here in the United States to sort of get some situational awareness. We'll then move into the much narrower space of smart technology infrastructure and some of the things that Steve was mentioning in terms of how to deploy some of these technologies in our cities and communities. And then I would just want to walk you through some of the way that the industry has typically solved these problems and the way that a new solution that we'll be talking more about today is solving those problems. So I think without further ado, we'll jump into the first segment here. I think for all of you, you likely know that solar since the 70s has certainly been on the rise globally and in the United States. We've actually made it up to now about 4% of annual generation here in the United States. And even just last year, it was a very significant portion of new generation, but of course, that is skewed quite a bit by the significantly declining investments in fossil fuels. But I think if you look across the globe and you see the major countries that have been playing in this space, you see that the US is certainly a global player with about 13% of global deployments in solar are right here in the United States. And actually, if you account for nuclear and hydro, we've got about 39%, about 40% of US generation is coming from clean power, which coincidentally is about the same footprint of the building sector. So we're powering approximately the building sector's worth of power in the United States with low carbon fuels, which is excellent. But we also recognize that while we may have a lot of solar, we don't have as much when on a relative scale compared to what other countries have been doing. Actually, Australia seems to top the global ranks with about 15% of their total electric generation coming from solar. And you can see that a number of countries, the EU overall and others top the US, and many of those numbers are only rising. And the question is, where do we want to be and where do we need to be in the 21st century? And if you take a look as well at the recent months and years, you see that actually since 2020, it's the first time that we've seen renewable energy as a total in the United States eclipse the amount of energy coming from coal. So we have a positive piece of that trend line there. But there's a whole lot more to go. And certainly as we decarbonize, we recognize that there's much more investment needed in this area in all kinds of scales and all kinds of ways. Some good news is that prices do continue to fall. There's an expectation of a number of technologies, and in particular of solar, that it follows a pretty precipitous path towards very low cost. I don't think it can ever get to zero, unfortunately. But we've seen it drop as low as 50 cents per watt when sold, which is an average selling price. It's not what a consumer would typically experience. At a residential scale, you'd probably see something maybe as low as $3 per installed watt, or closer to $2 on the utility scale. And of course, federal and other types of incentives, state and local, could help drop those numbers further. But if we look at global solar deployment and where it's growing and where we might actually see further falling prices, we see that, yes, the United States is increasing our solar supply, but especially you see it in China and also in the non-OECD world. So there's a lot of parts of the rest of the world that are starting to turn the corner on their solar deployment, which overall should help to reduce prices further for us. But we have a lot further to go still, and a lot of room for improvement. When we look here at Texas, we know we have a lot of sun. We know we have a pretty darn good solar potential. And even the Inflation Reduction Act, which passed just this past summer, promises to invest now $300 billion or more into renewables, efficiency, and upgrades in infrastructure, including solar and storage. So we have great potential. We know we can do more. The federal government is maybe this time here to help. And what we have from recent data from the Energy Information Administration and also from NREL, the National Renewable Energy Labs, as we see that actually a large chunk of the US solar deployments are happening in Texas. Now, that's primarily at the large utility scale, but it's impressive for us here in Texas because it puts us ahead of California on one of many, many metrics. And that's always a point of pride. Also in Texas, we have a whole lot of these systems off the grid and often uncounted. I think it's very difficult. I found it difficult to find the data on how many poles there are, how many of these off-grid systems there are. I'm sure individual jurisdictions might have some of their own counts, but it's pretty difficult to get a number. Across the country, it's probably hundreds of thousands, if not millions, of these types of systems. And they're typically deployed for traffic signage or maybe temporary systems that could be wheeled in for events or in traffic situations when patterns are changing. You might have remote gate entry, often in the Texas countryside, maybe for green retrofits, which is something we'll talk a little bit more about today, or in smart city applications where we have smart technology that's in high demand to deploy all kinds of new, exciting, and really potentially life-enhancing technology, and yet how best to power it. And that brings us to some of the challenges for how, in this more narrow segment of the industry, how do we energize and power a lot of these systems? So by and large, we're now talking about systems that are off the grid and not on the grid, and might be the harder ones to count, but they're certainly just about everywhere. So if we look at smart city infrastructure, there's effectively an insatiable demand for it. We have major companies moving into Texas all the time that are focused on all kinds of these technologies. And the only way that many of these things work is by having sensors and controls and telecommunications and connectivity effectively universally deployed. And so with that, we have a very strong need for new technology deployment. We also have the need for environmental sensors, especially with a changing climate and more human pressures on our state and on our environment, having a better sense of what's happening, and increased safety. Certainly since the pandemic, we've seen all kinds of different changes in the safety landscape in cities and around the country. And there's a lot of demand for public safety technologies as well. And all of these need power. Many applications wouldn't need an off-grid system because it'll be adjacent to or literally attached to your building or where you have power existing. But you'd be surprised at how many locations have power, but they don't have it precisely where they need it. And the question is, how do you energize those technologies, and where do you get that power from? Now, unfortunately, powering smart technology is actually not always that smart. You typically end up with a very slow and expensive process of running overhead wires or underground cables, digging trenches, potentially harming tree roots for old valuable trees, or through parking lots or existing pavement, plugging into the grid, which is of course greening, but slower than we need it to. And we know that at the same time, all of these excess processes of connecting to the grid also take a lot of time, and the time is money, and it's also material. There's a lot of theft of copper wire, unfortunately, in the industry of electrical and construction. And if you're dealing with alternating current, you also are dealing with high voltages and amperage, which tends to require far higher degree of safety and controls, and also higher paying licensed contractors and electricians. And what's surprising today, or I think is very welcome and good news, is that low power technology is really here to stay, and it's only improving. And so while we have more and more of these devices to power, on average, the power consumption of these types of devices are generally coming down. And so it tends to mean that we can do a lot more with the same amount of, let's call it 60 watts that we used to use to power a light bulb back in the 20th century. We now can do a whole lot more with 60 watts. So we can energize a number of different things or energize smaller things for less money, because it doesn't actually require that much power. So we have the lower power hardware. We have event-driven activity, which means it doesn't always have to be full power all the time. Of course, LEDs are a big piece of this equation, and even edge computing, doing some of the computing in smaller bundles and packages and minimizing the amount of additional power draw on the system. So we have some of these challenges and changing landscapes in the smart city space. And what tends to be kind of obvious is that, well, we should probably just use solar for a lot of these applications. Well, because we don't have to run a trench underground and we don't have to run a wire overhead. And so why not use the power of the sun, especially in sunny Texas? It's up when the grid is down. We have, potentially often the opportunity to right-size systems to only provide as much power as you need. So you don't need 12 solar panels if you only needed one for a low wattage application. And there's a continual, thankfully, a continual march towards ESG and sustainability commitments, not only of cities and states, but business and individuals as well. So it seems to make a whole lot of sense to go solar. The ways that we have typically gone solar, even since basically the 80s, have often looked like you see on the right, whether it's a typical glass panel, which I used to install a lot of on the East Coast. We've got a lot of kind of these glass panel applications that are effectively bolted or stapled to the top of a pole. And that's the pretty common application that we've seen. I think the challenges, however, are more than one would have thought of previously. There's a lot of room for improvement. We recognize that, of course, the optimal angle for solar tends to be directed towards solar south, angled at effectively your latitude to maximize for the best angle of sun. But you end up with the challenge of not potentially collecting sun at all hours of the day at the best possible angles. And this is especially challenging in the winter, when if you have a cloudy day, but you have a sunny morning or afternoon, that angle may not fully be optimized. You often, with those types of systems I was just showing, you often are going to receive the package of parts that you have to put together on site, and you have to put the batteries with the wiring, with the solar, with the pole. There's a lot of different things that end up slowing down a project and potentially having room for error in the installation. You often also need heavy machinery, because you need to get up there to the top of this pole to service or maybe clean the panel. And interestingly, one of these panels, when it's up at the top of the pole, it's kind of like you have a sail on your watercraft, on your boat. I mean, it's acting as a wind lift, which tends to actually increase structural requirements on larger and more sturdy foundations, and can also decrease the effectiveness of your camera technology if that's what you're trying to energize. There's challenges from damage and vandalism, certainly from hail. Here in Texas, glass systems have been damaged in many cases. I think it was a big farm or a solar farm outside of San Antonio that experienced a very expensive set of damage from hail. Vandalism as well, with these battery boxes that just look like something to break open and steal. And we've heard a lot from our partners and clients and customers that this tends to be an issue. I mentioned the copper wire theft is a challenge as well. And typically with these types of manufacturers and these systems, you'll find that it's a fairly limited amount of backup power that's designed for it, and a 3 to 5 year warranty, which is potentially perfectly fine for consumer devices, but we're deploying these in the field. So our understanding, anyway, after spending about a dozen years in all of this technology at our company, is that we think we could do a lot better. And so we here at PowerStack have come up with a term that we call vertical solar, and we think that and we know from our customers that it's starting to solve for a lot of these types of challenges that come up in outdoor power and off-grid systems. So you'll see it's vertical, which is a bit of a surprise, I think, for those that have been involved in the solar industry. And it's also, it looks sleek, but it also looks like a pole. If you open your eyes, as I have done, to driving around or moving around Texas or the United States, there are poles absolutely everywhere, and many of them are black, many of them are square, and these could fit right in. And so one of the major things that that PowerStack, my company here, has thought about is how do we solve for some of these problems while also solving for the real challenge of the aesthetic integration into the built environment and landscape. And we think that we've done a really nice job optimizing form and function in our design and our system. Of course, I mentioned some of the angles of the sun, what we lose in the ability to capture midday sun at its zenith, we make up for in the winter, because on a off-grid system, you're not optimizing for the summer. You don't really care about the summer, because the summer you always have all the sun you really need. What you're optimizing for is the winter, and you need to make sure you get it from every angle at every opportunity. So that sun is not going to be vertical overhead. It's going to be pretty low in the sky. It's also going to come at various hours of the day. And we even get the benefit in our application on vertical solar in having the ability to get reflected light, which ends up making up for some of the inefficiencies of going vertical on any one face. What it also means is that a 360 deployment means that you don't have to necessarily worry about the orientation of your piece of vertical infrastructure with your building site, your road or pathway. Whereas often with other systems that have an angle, you end up with a light or a system that ends up being out of whack and out of sync with the built landscape. So we have the ability to deploy in just about any 360-degree angle or situation, and to redeploy, meaning that it doesn't matter which direction it's facing, because the next time it'll work the same as it did last time, even if it's facing 90 degrees differently. Well, we like to say that it takes a pretty talented bird to make a mess of a vertical solar panel. You can spot any types of mess that's made on a vertical solar panel. You can address it pretty quickly with a hose or a broom or a mop. And you don't need a bucket truck to get up there and service a vertical solar panel just to clean it off, because it's right there in front of you. If you need to stand in the bed of your pickup truck, that's one easy way to do it. We've also innovated on this technology because we recognize that there was something to be improved upon with the glass. And so we've actually taken glass out of the equation. We're using a very sturdy and resilient polymer-based module for the solar that can really take a beating. And I'm happy to show you a little bit of that in a minute. We've actually upped our confidence in our battery solution for a 10-year warranty and a 5-day battery backup for the system throughout its life cycle. So that means that at the winter solstice, in the darkest time of year, we're designing our system to make sure it can last, pretty much a whole week if you end up in that kind of darkness. And the slender system complements or is a departure from the sail that I was talking about earlier, allowing for a lower amount of effort in the foundation, so lower structural requirements, and also it can slot in pretty easily into just about any situation. Here's an example behind me, which is at a bus stop, and a bus stop is a very narrow, kind of postage stamp piece of real estate, where if you have a wider system, it can be really difficult to slot into the urban landscape. So we've got form and function. We've also got ESG and compliance that we've been thinking carefully about. On the permit side, as Steve mentioned, many jurisdictions, such as the city of Houston, do not require an electrical permit for systems that are under 50 watts and under 50 volts. The system that Steve was mentioning was installed in Houston recently. Was under these thresholds. We could get a bigger system that could potentially go above, but a lot of these systems end up being under that threshold. We're also Buy America compliant and have UL listed components. The entire assembly is not UL listed, which goes back to the many dialogues we've been having with UL in terms of what category do we fit in anyway. So we're still solving that, but it generally has not been important for our applications and has not been thus far required. And we're proud of the UL components that we do contain. And of course, for any structural attachment to the ground, you're going to end up with some kind of foundation requirement. If you're adding a new foundation, that's probably going to require some kind of structural building permit. And as always, consult your local code officials and building department to make sure that you're running appropriately. I think, Steve, you might have had something to add here.
Yeah, I just wanted to basically verify that that threshold with the NEC is for real. You do not need to get a permit if you're under 50 watts and 50 volts. And, you know, so it's not like an electrical permit is the end of the world. And I'm not suggesting that we don't want to support municipal governments and, you know, health, safety, and welfare protection for inspections, but the NEC is extremely clear about this, and that's what the city of Houston goes by.
That's great. I think it's fair to say that not every jurisdiction does it the same way, but Houston does and many others do. So read your code books. We've also been thinking a lot about the applicability to lead credits. My company here at PowerStack, we'll talk a little bit more about that in a minute. We're very committed to ESG and sustainability, and we recognize that while you can't necessarily earn a lead point by buying any individual product, you certainly could contribute to the sustainability credentials of your project to make it more likely to earn credit, whether it's in sustainable sites for light pollution reduction, because we can add very easily light controls. Pretty much everything we've ever installed from a lighting perspective, or sold, I should say, from a lighting perspective, has been full cutoff and dark sky compliant. Of course, you can add whatever luminaire you really want to a PowerStack, but pretty much everything that's gone out there has been that way. Lighting controls, of course, can be calibrated to make sure that you have reduced run times and really optimize the amount of light that's needed when you need it and cut it off when you don't. Of course, there's renewable energy and potentially incentives that are both federal, state, and local for your project. In the materials and resources category, you have the building lifecycle impact reduction, which really could be an interesting one to add the PowerStack system into, as it's minimizing all these other carbon consuming processes, from trenching and the materials that go into conduit and wire at 3 feet underground, the heavy machinery that's used to install and to dig. So I think there's a really interesting opportunity to add an outdoor power vertical solar solution into your lead submission on this one. And of course, it's an innovative way to bring power outdoors. To show you a little bit more about what the PowerStack system entails, we call it PowerStack because we stack power. We can run from 3 feet tall to 25 feet tall, and the surface area of our pole is covered in as much solar as is needed for the application that's required. So it doesn't need to have solar all the way up and down, but it certainly can. And of course, a shorter pole will have lower solar power generation potential than a taller one. And on the inside, we're also stacking power because you don't really run systems off of solar. You run them off a battery that is charged by solar. And that battery will therefore be stacked, actually concealed on the inside of the pole, which makes it very vandal resistant and not very tempting to those who are interested in doing some harm on public infrastructure. It's pretty hard for them to find what to do with the system. We can also be modular in how we deploy the payloads on a PowerStack with spacer modules that can allow you to have a camera at a certain height, or a light at a certain height, or a charger at a certain height, whatever it might be. So it can be a customized solution, and there are a number of things that have been deployed that could be repeated. I may have mentioned, although I remember I was talking to Steve a few minutes ago, so maybe I just mentioned it before the presentation, but the installation and the service of a system like this one is really exceptionally different than most other systems. In fact, the fastest teams that have installed a PowerStack, the ones that have been most prepared, have actually done so, including the foundation, in less than a half an hour, 28 minutes. And that can be done really for two reasons. One is because the system goes up and down on a hinge, which means you don't need a bucket truck, and you don't need a front end loader, and you don't need a forklift, an extended fork to dangle a pole over and to install it in place. And you can use a winch and a hinge and our hinge pin, and it comes up in just a few seconds. And also because of the foundation, really exceptionally because of the foundation, of course, this pole could be installed just like any other on a concrete pad, whether existing or a new one. But the preferred installation method would be lower carbon and concrete free. And it effectively acts like a taproot or a tree root under the ground. And you have a series of piles that are drilled in, just kind of hammered in. And I can show you that really quickly on this video that will be without sound. And what you can see here is a team drilling these diagonal conduits in and tipping that pole up really quickly. It's an impressive difference than the typical way that a pole would be installed, and certainly the speed is second to none. I mentioned that there's a number of different ways that you could use a system like this one. It doesn't have to be for lighting. Steve was mentioning in his application in Houston that he was thinking about Wi-Fi and cameras and all kinds of other things. And really, PowerStack is a power supply. And then it's often used as a light and a camera. And that camera tends to have a modem with a 4G connection to send that data from the camera somewhere. That's, again, what I have behind me in an installation in Austin. But it could be any number of other things. We've had the concept of a nest for drones to recharge on their way out to missions. We have installed, and with happy customers, device chargers for mobile devices in public parks where the municipality is interested in extending connectivity and Wi-Fi access. This has been a common application in some of the Australian part of our business, where we have a number of installations as well. We manufacture on that side of the ocean as well. So there's a lot of different things that you could do with a PowerStack. It's not limited to any one of them. And I mentioned that there's some damage and vandal resistance to the system. I mentioned the glass free panels, but I think it's worth seeing what it looks like to really try to beat this thing up a little bit. And so you'll see here that up close it looks like solar, but you'll see that it's not glass. It couldn't take a baseball bat, pretty angry kicks, a skateboard, or coming up a firearm. Here's a rock test, or a firearm, really, without a polymer-based, non-glass solution. It can handle pretty easily. You saw the spray paint, and it just wipes right off with the standard cleanser. And so there's a whole lot of applications in the urban environment, or even an industrial landscape, that could be improved, or it could be resilient to, if you end up with a system like this one. And what I wanted to highlight as well, just yesterday I was in Houston celebrating the ribbon cutting of a new Spark Park that Steve was mentioning. And in that park, which is designed to use the school ground as a public space after school hours and make it a more accessible green space for the community. In that park, we have a charging station for a 4-port charger. You can bring your mobile devices to it and charge them while standing next to this crazy game that the kids are playing these days. I can't remember what it's called, but you throw the ball at people's knees. Anyway, it's very popular end of the park, I'm told. The system is actually our first installation in North America of this type of PowerStack. And what I think was really impressive to the installers, as well as the assembled group there when we did the install, the contractors did the install, was it took 20 minutes. It came from off the transport and straight into the ground with a hinge and a bolt, and that's it. So there's a lot of interest in situations like this one, where there may be a permit challenge, or there may be an opportunity to bring solar, which is part of the mission of this organization, into public spaces. And even, with Hurricane Harvey and other rain events, there is a risk when you install electric infrastructure, no matter where you are, that there is some kind of rising water and what that could do to outdoor electronics. In our case, we elevated the internal electronics to no lower than the shelves of the charging station. So 3 feet of water that, this pole could take on 3 feet, no problem. Now, there may be other problems all around the neighborhood, but the PowerStack would not be impacted. And you'll also see here on the right that the community and the nonprofit was excited to label the pole themselves. Here's a few photos from yesterday, including one of me and Steve. We've seen a lot of each other recently, it seems. It's actually at the Mandarin Immersion Magnet School on the west side of Houston. It's now open to the public as of the ribbon cutting yesterday with the big scissors. And we're excited to have that installed and share that with the public. So I wanted to just spend a little bit of time on the life cycle costs of a system like this one. I think it's not hard to understand how a system that has power and and solar and battery storage and everything on the pole itself is going to be a more expensive piece of equipment than a pole that just has a wire running through it to the grid. There's no question that the hardware itself will be more expensive, and you can see that. But when you add the foundation in, you'll see that there's even more, because we have a more affordable foundation solution that we like to use. But it's really the installation that kind of dwarfs the different numbers. And really the installation comes down to running that power. Oftentimes it's only 20 yards from one place to the other, but it can be anywhere from $15 to $50 a foot to run that power. You often will run into scheduling problems because you'll find out about a underground utility or a tree root or rocks or something like that. And you certainly have permit time, which can add up, whereas the PowerStack can move really quickly. And so even on a first cost basis, we found that for our customers, they're choosing PowerStack because the first cost can actually be oftentimes lower. And even over the 20-year maintenance, which will include a battery swap out, the battery swap out plus the checkups on the pole just to make sure everything is functioning correctly, appear to our customers to be approximately half the cost of taking care of an AC pole. And the research there was done by the city of Los Angeles to understand what it costs them on an annual basis per pole to take care of even just one streetlight. And so what we see in this application is that if you care about first costs, as unfortunately a lot of our accounting systems do, PowerStack can often slash your first costs. And if you care about life cycle costs, PowerStack can help there too. And if you care about cutting carbon and being part of the smart city of the future and providing really an ESG forward solution, we believe that PowerStack can often be a really good solution for your project. I have a lot more information on the cost estimation, cost analysis, but just to show you a little bit, this analysis was done on a 25 pole installation. It was for lighting. It was for 4,200 lumens and a 30 watt fixture that could power that. and 12 hours a night, and do so in Austin, Texas. And so there's quite a bit of math that's gone into all this, but it's a pretty conservative assumption on our side that we believe that, and our customers have found, the PowerStack can very often be a cost-effective solution in addition to being an attractive one and a resilient one. I wanted to take the last few minutes before opening it up to questions just to show you some of the examples of what PowerStack can power. We like to divide it up into 4 different categories of connect, charge, monitor, and light. So I'll just walk through some of those now. So on the street lighting front, here are a few examples on a roadway. Some of these are higher speed or lower speed. The one in front of the house here on the right is outside of Houston, Texas, just to the south in Angleton, where it's a pretty low speed roadway, but the community selected the PowerStack pole and light arm because they thought it fit into their aesthetic, and they were excited about owning the infrastructure rather than paying a continual bill to infinity to the electric utility. So at some point in a few years, the cost curves cross, and owning your own asset ends up being the much more affordable solution. For pathways and parking lots, it's very attractive to use an off-grid system because you don't have to dig up the park, you don't have to dig up the existing parking lot, you don't have to dig up the street. Also, because of that hinge system, you don't have to shut down the street for a bucket truck with cones and traffic control. You can just hinge that down, and all the work is done safely at grade. Bollard pathways or pathway lighting is another option for a shorter system. You can see here that there's less surface area for solar collection. There's less storage area for batteries, and there's less storage area for the types of controls in the system. So a smaller PowerStack column would have a lower power capability. But that's why we end up stacking more as needed. A pretty common application I mentioned, and this is the one that is also behind me. We were working with Cap Metro here, the public transit organization here in Austin, Texas, where we're located and where we manufacture just outside. And here in this 15-foot tall system, we're able to power a light all night, a security camera, and a router modem that's communicating back to the central hub, so that they can monitor their bus stations. In other places, we found that parks and parks officials have been interested about adding eyes on illegal dumping sites or other types of monitoring that might be needed. I mentioned that Wi-Fi in public parks is popular. This is a couple of examples from Australia, where the community was excited about providing Wi-Fi in a public park, and they didn't want to have to figure out how to do it with wiring electrical power out to this particular spot at the center. It's also popular along some of these pathways along the water or in existing hardscape they don't want to dig up. And here's a charging station, like I showed you in Houston. We've got a couple of others installed. It could be a 3-foot version or another tower. The tower that Steve and I were standing next to and that you see here on the right is 10 feet, but it could be 25 feet if it needed to do a bunch of other things, or if the aesthetic requirement was for 25 feet. And of course, any combination of those types of things could be possible. Of course, it's not limitless. The sun only sends us so many photons in Texas, but there are a lot of opportunities to combine these different payloads and services. There's just a handful of examples you can see here on the bottom. There's a little fun sunset picture from our facility where we manufacture in Dripping Springs. So we are Texas made and Texas local, and excited to work with folks all across the state, and certainly outside the state as well, where we have deployments in California, in Canada, in the Northeast of the United States. And as I mentioned as well, we have a sister company in Australia that's working over there as well. So we're pretty excited to work with you and eager to find ways of collaborating. And I hope that you found a few things that are new and interesting in outdoor power and in vertical solar. And I think with that, we'll take the opportunity to look at some of the chat and questions, and maybe I'll turn it back to you, Jonathan or Steve, to help facilitate that.
Thank you, Jeremy. We have had a few questions come in, kind of one looking at some of the specifics of kind of what your product is, looking at what are the dimensions? Is it a 6x6 on the size. I think you already answered the question about, are there solar panels on all four sides?
Yeah,
So
good question. Yeah, so there are, so we tend to put solar panels on all four sides. There's no reason why we have to do it. If there ended up being a situation where a pole was being bolted against the side of a building and it would never receive reflected light, and it would be better deployed on another face of the pole, we certainly could do it. Our system is very modular. But we found that because the system is so easy to redeploy, and that solar is much cheaper, as you saw, than it certainly used to be, the system is often optimized with a full set of solar around all sides, and you can end up redeploying it however you like. The dimensions are 7 inches square for our current model. We're looking at other sizes and dimensions that could potentially help with some of our customers and their power needs, but 7 inches square on the outside, and we have about a 5.5-inch square cavity on the inside in which we store batteries and controls and wiring, other types of devices, Bluetooth, cellular, you name it.
Okay, there have been a couple of battery questions as well. One had to do with keeping batteries cool in that type of an application. And how have you addressed that?
Yeah, so we use lithium iron phosphate, which is one of the more stable and well-practiced, well-understood battery technologies. When we end up with millions of PowerStacks out there, we'll probably be able to manufacture our own batteries and do it our own way. Here in the United States, we have to source them because we're, like pretty much everybody, you're getting batteries from some other source. How do we keep them cool? Number one, there's a stack effect inside the column. So there's constantly, the bottom is actually open air, which allows for air to flow up and past them. But we also understand from our systems that the batteries actually operate quite well at a pretty wide range of temperatures. And that stack effect is helping with convection cooling. And we run a series of insulators around those batteries. So they're actually not fully snug within the pole. They've got an insulation layer around them. And we've not found that they've been a problem. If you're going to get overheating, you'll probably get it in the summer, which of course could drag down your efficiency. But the reality is we have an excess of power in the summer. So that's not really what we're optimizing for. We're much more careful around how we might lose efficiencies in the winter, because that's really when the system is limited.
Okay. There have been a couple of questions here. I'm going to roll a couple of things together, kind of looking at, are all the pieces custom designed, and or are there standard electronics that can be powered using the system?
Yeah, it's a great question. Effectively, we are, at our stage right now, we are making most of our systems in a made to order capacity, which ends up being fairly custom. There's often, a certain camera needs a certain modem and a certain thing, and we'll work with your contractor security integrator, your lighting integrator, that ends up designing what those systems are with some of our input in terms of how to right size those systems and potentially keep the power requirements down, so that we can give you more pole and more power for your money. But because we've now deployed hundreds of these across the US and North America, we have a number of systems that have been tried and tested. And so that can be a shortcut. If you just want the same thing that somebody else got and we know it works, there's no reason why we have to re-engineer and reinvent it. So I think there are shortcuts, and in the future, we intend to have more off-the-shelf models that are, fully packaged. The challenge when you work in off-grid systems is that a system that is really perfectly engineered for Central Texas may not be the same system that's perfectly engineered for Missouri, and it just has to do with how much sun you're going to get and the length of the season.
Okay. So speaking of kind of those combinations, there was a question about the system that's installed in Houston with Spark. What is the cost range for a system similar to that?
Well, a 10-foot unit and the 4-part port charger, I'd say you're probably in the range of somewhere between $6,000 and $8,000. And because the installation can cost you, 20 minutes, you got some shipping and handling, it's a pretty affordable solution for, I think, that kind of application. At the end of the day, PowerStack is an OEM. We're a manufacturer. We're not an installer. We love training others to install. So there will be some variability in terms of what that contractor that you choose or we end up choosing with you might need to charge because of their capacity at the time or their understanding of the difficulty or simplicity of the system. But yeah, we found that with our customers, they've been pretty happy with that pricing. And I think the full range, to answer a broader question, would be that, when it leaves the factory doors, those little ones at 3 feet that could do lighting or a little, charging station next to a park bench could be, as low as $2,500. And a full 25-foot pole, which is the largest that we can get our aluminum extrusion, could be on the order of 12 to 15,000 when it's got all of its bells and whistles attached to it. And it just kind of depends on what the power application need is. And hopefully, we can design a system that uses even fewer watts, which means we can use fewer batteries and fewer photovoltaics and potentially fewer feet of material, all saving carbon and money while giving you the application and the technologies you need.
But, I know you talked about a lot of these are custom designed for the specific application. There's a question on the duration of lighting provided from some of the systems, as well as how long it takes to get to a full charge.
It's a good question. The duration of lighting is entirely up to the user's design. If the user tells us that they don't ever want to light to illuminate more than 4 hours a night, we can run a model for that, and we can therefore use a whole lot less energy generation and storage because that's a much smaller powered system. Some will say that, we're lighting a pathway between our building and our parking lot, and it needs to be on 24, not 24 hours a day, but full night all the time. And so over the Christmas holiday, it's running full night. That's the darkest time of the year. That's going to be 12 hours or so, maybe from 7 to 7. And so that's just part of the energy model that we would develop together, and that would determine how to manage for that amount of electricity consumption, power consumption in the winter months, which is how the whole system is designed, because in the summer or the shoulder months, we'll always have more.
Okay. That's something that, Jeremy, you touched on briefly, and you and I have talked about in the past. With this system, can you discuss more about the redeployment of these systems, especially for use in something like a construction application where it is only intended to be a temporary solution?
Sure. Yeah. So we have, because of the hinge design, which is, it makes it really easy to install it and uninstall it, even just with 2 people, a pickup truck, and a little hand crank winch. We've seen some people do it without a winch. We wouldn't recommend it just for safety, but it could be done. You end up with a very quick, maybe 15-minute, even faster time frame for getting the pole horizontal, and of course without wires. So it can be picked up, put onto a trailer, and dragged to your next location. The foundation becomes the question of what it will attach to. We have talked to some that have a big concrete block that they end up moving around for some of their systems, and that could have 4 bolts on it to receive a PowerStack. That could be one option to move a sturdy, footing around that lays on top of the soil. Another solution would be to move it from existing concrete pad to existing concrete pad, and you drill 4 holes and use those kind of Dynabolts in there. They set overnight, and now it's ready to go. But a probably more common option would be that you move the concrete-free foundation, or you redeploy it, I should say. Once it's really locked in there, you saw those rods being deployed. It's not coming out. It takes 7 tons of force to move it. It's really not moving, but it's only several, it's less than $1,000 to have a new foundation. And you can drop it in the ground in about 15 minutes. And so if the concrete free ends up being the right solution for you, you just install a new one, 15 minutes, and the one that you had in your previous location, you can either bury, because it's 4 to 6 inches beneath the soil, or if you're already moving things around anyway, you can kind of crush it or rip through it. But effectively, once it's installed, that thing ain't moving.
All right. So there was also a question too. What is your NASDAQ symbol? Because I think somebody wants to invest.
I wish I could offer that to you, but we are privately owned. But we would love to hear from you at powerstack.energy.
So I'll open it up if anybody else has any more questions. I think we covered all the ones that were in the chat at this point. Also, you could raise your hand. We can also unmute you and you can ask directly. Thank you, everybody. As I said before, if you would like the AIA certificate for this course, please send a direct message to me with your name to make sure that we get all the information that we need. Look forward to seeing you all with some of our presentations coming up. Steve, do we have December already set?
No, December is an off month.
Okay.
It's
So we will take December off, and looking forward to seeing you all next year. If you have specific topics or if you would like to present, please reach out to Steve or myself, and we will be able to try to add that into our queue. We've got one more question in here. What does the future hold for putting vertical panels on houses or buildings, etc.?
It's an interesting question. I have not done as much thinking about how it would integrate into buildings and houses. I think there's obviously ways to do it. In some of my past career, when I was working in the solar industry in the New York area, I was often working in building integrated photovoltaics, where you could offset a building material by introducing a piece of introducing solar. So you don't need cladding because you have solar, basically. So that concept has existed for quite a while. It's not typically cheaper than cladding. And what we're finding with our application is that while the vertical solar works really well for what we're doing, we're also not powering buildings and houses because we're powering low power devices. Larger systems in the future could do something different. But I think at the end of the day, the PowerStack system, because it was designed to be an inclusive off-the-grid standalone technology, it really benefits from having the multiple angles. So I think if you were just ending up with one vertical wall of a building, you might end up with a very different equation for how you model for that. And especially if you're inverting and sending it into the grid, I think there is a future there, but it's not one that PowerStack is taking on anytime soon.
Thank you, Jeremy. If anybody else has any other questions, please let us know. We've gotten several requests for certificates, so Steve and I will get together and make sure those get out to everybody. With that, I thank everybody for coming, and we will see you in the new year.
You bet. Thanks again. Thanks, Jeremy.
Thank you.